Okay, so this addresses the beginning of Chapter 2, where we're looking at systems of equations and developing some matrix methods for dealing with them. The basic idea is that, now of course for this system, we don't need any fancy methods. We can solve this lots of different ways. We could add the equations together or solve for one and substitute. But what we're going to be doing is transforming this problem into something related. We're going to keep the coefficients and the answers. So what just happened here? So I took this stuff and I placed it over here. And then I took all the coefficients and I put them into here. And this is called the augmented matrix. And the idea is this is an abstraction, a computational abstraction, because we could view this system of equations as a matrix. Once we learn how to multiply matrices, we could view this as as a matrix equation, and we will later on. So these are three equivalent ways of representing this problem. A system of linear equations, an augmented matrix, or a matrix equation. This is convenient for computations. And here's the idea. We're allowed to do certain things. There are sort of rules for how to deal with the rows of this matrix. And the goal, if possible, is to reduce this to something like this. So there are rules of manipulation that allows us to go from here to here. And what is this? Well, this represents 1x plus 0y equals a number, and 0x plus 1y equals a number. Well, what's that? That's just x equals something, y equals something. That's the goal of solving these equations, is to reduce it to the answer. So this is what we're looking to do. So these two things are the same, and later on we'll see this is also the same as the following matrix equation. And we'll talk about how these things, how to do all these things eventually. But for now, what we're looking to do is this. This is our goal. So what do we do? So let's go down here and try to solve this problem as an example. Again, this problem is a simple problem. We don't need the methods of 2.1 to do this. But it's a good start. So we transform, or we rewrite our equations into the augmented matrix. And then here's how it goes. Step 1. We want to make... Come in! Okay, that's how a student drove by. So here's what we're going to do. We've converted it. That's step 1. Now, it'll be helpful if we can refer to elements of this matrix. And the way we refer, to let's call it an address in the matrix, is it's row, then column. So this is the 1, 1 spot. It's the first row, first column. So we want, let's call it, say, A1, 1 to be equal to 1. So we'll call this matrix A. So how do we do this? Well, one of the rules of manipulation is we can multiply a row by a number. All right, so we can multiply a row by a number. So I'm going to multiply the first row by half. So we'll do, this is how I denote it. You take a 1/2 times Roman numeral 1. So this will indicate row 1. So if I multiply the first row by a half, I'll have 1, 1 half, 1 half. The second row is unchanged. Okay, nothing happens to it. 2. My next goal is to make this spot here equal to 0. Well, this is its second row, first column. So I want to make this equal to 0. Now, how am I going to do that? Well, I can add and subtract rows. So we can add rows and multiples of rows to other rows. And so what I'm going to do here is I'm going to take the second row minus the first row. And this will be the new second row. Again, notice that this problem is a lot harder doing it this way than solving it, these two equations, the way you would solve it right now. But the strength of this method is we can teach a computer to do this, a lot of if-thens. And then a computer can do it to a 100 by 100 matrix that you wouldn't want to remotely do by hand. It's no problem for the computer, it just does these steps over and over and over again. Alright, so let me fold this up. So if we take the second row, subtract the first row, what do we have? Well, we'll have the first row stays the same. The second row changes. 1 minus 1 is 0. Minus 1 minus a half is minus 3 halves. 2 minus a half is also 3 halves. Step 3. Now I want this cell to be 1. Second row, second column. I want A22 to be 1. I'm going to go back to that previous rule. We can multiply a row by a number. So I'm going to multiply row 2 by negative 2/3 times row 2, and this will be the new second row. So if I multiply by negative 2/3, what happens? Nothing happens to the first row because we're not operating on it. In the second row, 0 times negative 2/3 is 0. Negative 2/3 times negative 3 halves is 1. Negative 2/3 times positive 3 halves is minus 1. Now technically at this point, we have solved part of the problem. We have 1 plus, so we have x plus half of y equals half, and we have 0x plus y equals minus 1. So we do have part of the answers. All right? But we're going to continue with this process. For our last step is to change this into a 0. So I want A12, first row, second column, to be equal to 0. And to do that, I'm going to take row 1 minus half of row 2 to be the new first row. So what do I get? Well, I have 1 minus half of 0 is still 1. Half minus a half of 1 is 0. A half minus a negative, so that'll be plus. So it's a half plus a half is 1. Then I have 0, 1, minus 1 still. Okay, and now I'm done. X equals 1, y equals minus 1. And let's check. So if x were 1 and y was minus 1, you'd have 2 minus 1 is 1. Yep. If x is 1 and y is minus 1, I'd have 1 minus a minus 1 is 2. it works. All right. So when you get to this stage, you're all done. Okay, I'm going to do another example of this, but there's your first pass.